In this section, we're going to be solving logarithmic equations. And one thing about logarithmic equations is you are going to have to check your answer. So as it states here, it says you must substitute the possible answer into the argument. So what you see highlighted here, of course, this is the part that's referred to as your argument. You can have any type of expression here. It may be 2x plus 1, it may be x squared, but whatever expression you have here, you have to substitute your possible answer there. And make sure that it does not cause that argument to equal 0 or to be negative. If it does, then you're going to have to throw that answer out. So once you substitute your answer back in, it cannot make it equal 0 and it cannot make it equal to a negative number. Alright, we're going to look at actually two types of logarithmic equations. And the first one that we're going to look at is going to be in this particular form, where we have a log expression equal to just some number. So first of all, you need to make sure though that you do have just a single log term on that one side, and that needs to be on one side by itself. Once you get that taken care of and you have it where it looks exactly like this, then you'll go to step 2, which is to change it to exponential form. Now if you remember back in an earlier section, we talked about changing to exponential form. So if this represents my log form and I go to change it to exponential form, it would be b to the y is equal to x. So this is what you use for step 2. Now step 3, I've just said solve for x, because once you change it to exponential form, it'll be a type of equation that you will recognize at that point. Okay. First one that we're going to look at we have log base 2 of x plus 4 is equal to 5. Now this one is already exactly the way it needs to be set up. So as far as what I referred to as step 1, there's not anything to do. You've got just that one log expression there on the left and equal to a number. So you're ready for step 2, which is to change it to exponential form. So that would mean that I have 2 to the 5th power is equal to x plus 4. Okay, to get x by itself, you will have to subtract the 4. Of course, you can go ahead and calculate 2 to the 5th. So we'll have 32 minus 4 is equal to x. Therefore, our possible answer, it's just referred to as a possible answer until you actually check it, is going to be x equal 28. Now, if you take 28 and you substitute it back into the argument, so your argument is the x plus 4. Of course, that would be 28 plus 4, which is equal to a positive number. Again, as long as it doesn't equal 0 or equal a negative, it's got to equal a positive, then you're good. So 28 would be your answer here. Okay, next example. Okay, now again, as far as step 1 is concerned about having a single log on one side by itself, this one is set up for you. So this one, you go to step 2, change it to exponential form. So we'll have 3 to the 2nd power is equal to x squared. Okay, go ahead and calculate the 3 squared, of course, which gives you 9. Alright, so you end up with actually a quadratic equation. You can use your square root property here and take square root of both sides. So that's, of course, square root of 9 is going to give you 3. But remember, you would get positive 3 and negative 3. Now, I'm just listing them separate instead of using the plus minus notation, because it's possible one checks and one doesn't. So I may need to come back and mark one of these out. But take these and you bring them back up here and check them with the argument. Alright, so if you put in negative 3 and you square negative 3, you get a positive 9. So that means you get to keep your negative 3. Of course, also substituting in positive 3, 3 squared is equal to a positive. So it always needs to come back to be a positive value once you put it in your argument. So this one has two answers. Okay, the next couple of examples, instead of having log, we're going to be looking at problems that have ln instead. But we're going to follow the same process. Again, step one, you want to have that single log on one side by itself. Now, this one, though, I've got to do some work to make that happen. Because your log, see, is just this part right here. So you need it to be by itself. Since the 4 is being multiplied times the log, your first step here would be actually to divide both sides by 4. So your 4's cancel. So we end up now with the natural log of x minus 1 is equal to 3. Okay, so now step 2 is the same. You've got to change it to exponential form. Now, since we've switched over here to having an ln, you've got to remember you've got an understood base of e. So I would have e to the third power is equal to x minus 1. Okay, now to get x by itself, you would have to add 1, so you have e to the third plus 1 is equal to x. Okay, now like on these problems, you're going to see that they'll just get a decimal approximation because e is irrational. So just entering this into your calculator. And I can't remember what your homework section has you to do on rounding, so I'll just do a couple of decimal places here, but just make sure you follow the instructions on your homework with rounding. So we'll call it 21.09. So you end up with 21 9/100. Okay, next one. Okay, now this one is similar to the one I just finished. I do have a little bit of work, again, that I need to do to get started, because I do need the natural log term here by itself. So that's going to require this time that I subtract 4. So I would have natural log of 3x is equal to 5. Again, you've got ln. So your base is an understood e, so when you change this to exponential form, you'll have e to the 5th power is equal to 3x. And then to get x by itself, you have to divide by 3. And put this in our calculator and approximate this. Okay, you should get approximately 49 and 47 hundredths, 49.47.